In 1815, Mount Tambora in Indonesia erupted, sending an estimated 160 billion cubic feet of ash and pumice into the air. It was the most violent eruption in recorded history, so violent that it triggered a worldwide volcanic winter. Crops failed, and an estimated 88,000 people died. And although we can't say for sure when the next supervolcano will erupt, scientists may now have a better idea of where it could happen. A new study published in Nature this week reports the first ever prediction of future supervolcanic eruptions, which could help researchers better understand these rare but devastating events and hopefully save lives in the process. Supervolcanic eruptions are the stuff of disaster movies, spewing massive amounts of ash and debris into the atmosphere and causing global devastation. But they are actually pretty rare. There have only been about 4 in the past 10,000 years or so, with the most recent being the 1980 eruption of Mount St. Helens in Washington state. It's hard to predict when one might happen again because you can't just stick a thermometer in magma to check its temperature, and unlike smaller volcanoes, supervolcanoes don't give off much in the way of warning signs before an eruption. They often show no signs at all until it's too late. So understanding what leads up to an eruption is critical if we want to try and forecast them. For this study, researchers took a deep dive into the history of 12 supervolcanoes in the United States, looking at things like their size, shape, location, how long it's been since they last erupted, and the composition of their most recent eruption. Then they ran thousands of computer simulations to compare real-world factors like tectonic plate movement with what would drive the formation of magma chambers beneath the Earth's surface. The goal was to identify commonalities among these different supervolcanoes. What was driving their eruptions? Was it magma coming from deep within the Earth or rising from shallower depths? How fast was it moving? How big were the magma chambers? The researchers also gathered data on earthquakes that had happened near the 12 sites, both before and after the eruptions. They wanted to know if there were any telltale signs of magma moving beneath the surface leading up to an eruption. What they found was that the majority of these supervolcanoes seemed to be driven by the same process, magma generated deep within the Earth that slowly made its way upward, pooling in a magma chamber beneath the surface and eventually erupting once the pressure exceeded the strength of the rocks above it. In other words, a buildup of pressure over time caused the eruptions. This kind of eruption style isn't unique to supervolcanoes. Smaller volcanoes can do the same thing, which means that something else must be different about the larger ones. The authors think it has to do with how quickly magma is generated deep within the Earth. Basically, it's the difference between a bathtub filling up slowly and steadily versus a giant wave crashing into the tub. When the tub fills up slowly, there's a chance you can drain it by turning on the faucet. You can keep the water level low enough that it never overflows. But if a giant wave crashes into the tub, you won't be able to drain it fast enough. The water's going to spill over the sides no matter what. Scientists think the same thing happens with magma. If it's generated slowly and steadily deep within the Earth, the magma chamber can slowly fill up without overflowing. But if there's a sudden increase in activity, generating lots of magma very quickly, well, that's going to lead to an eruption. But while this model explains how supervolcano eruptions happen, it doesn't necessarily give us any more insight into when they might occur. The researchers wanted to take things one step further and use their model to predict when the next eruptions might happen. To do this, they used data on the frequency of earthquakes near each of the 12 supervolcanoes to estimate how quickly magma was building up beneath the surface. This earthquake data is publicly available, and the hope is that having a way to predict eruptions based on more easily obtainable data like earthquake frequency could prove useful. Using this approach, the team identified 3 locations that may be due for eruptions in the next several thousand years: Medicine Lake in California, Mount Mazama in Oregon, and Yellowstone in, Wyoming, Montana, and Idaho. All 3 are currently considered active, with Medicine Lake last erupting around 400 years ago and Mount Mazama about 7,700 years ago. Yellowstone, of course, is famous for its super eruptions 2 million years ago and again 640,000 years ago. It's been quiet since then, which is part of why the researchers chose it for this study. Yellowstone is also unique because scientists have been monitoring it closely for decades. That means they have lots of data to test this new predictive model, and the results are promising. The model accurately predicted that magma generation at Yellowstone increased around the year 128,000 before it erupted again about 640,000 years ago. Now, this isn't exactly a recent development. Scientists have been watching magma chambers under Yellowstone for decades, and they already knew another eruption was likely at some point. But this new model provides a potential framework for predicting eruptions at other supervolcanoes as well, which is important because unlike Yellowstone, many supervolcanoes aren't as well studied. Take Mount Vesuvius in Italy, for example. It's home to the famously preserved ruins of Pompeii. But it also sits near Naples, a city of almost 1 million people. That makes it potentially much more dangerous than Yellowstone, which is mostly wilderness. But scientists don't have nearly as much data on Mount Vesuvius. The new model might not be able to tell us when the next eruption will happen, but it could help focus monitoring efforts where they're needed most and hopefully give people in high-risk areas a little more time to prepare. Now, you probably noticed that Mount Mazama, which includes Crater Lake National Park in southern Oregon, was included in the list of volcanoes that might erupt in the next few thousand years. And that might be surprising to some because Crater Lake is, well, a lake. Crater Lake formed after the most recent eruption of Mount Mazama about 7,700 years ago. Ash from the eruption created a layer 230 feet or 70 meters thick across much of the Pacific Northwest. And after the volcano went quiet, rain and snow filled the caldera, creating the deepest lake in the United States. Now, Crater Lake is popular with tourists, and the surrounding national park sees over 1 million visitors every year. So if Mount Mazama were to erupt again, well, that would be pretty bad. But the good news is that it probably wouldn't happen anytime soon. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So to all of our patrons, thank you for what you do to make this happen. If you're not a patron but you want to learn more about what that means, you can go to our support page.